An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Teahupo'o tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Loddalen Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland Mega-Tsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano Mega-Tsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo Mega-Tsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The Mega-Tsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam Mega-Tsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The Mega-Tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of 3 large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard.
Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes, and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Two sailors were traveling not far from the infamous Bermuda Triangle when they noticed a boat that seemed to be moving by itself. The sails on it were down and the motor wasn't running. One of the men was Matt Rutherford, the first man to ever sail non-stop on his own around North and South America, who has seen a lot during his voyages. But this one was spooky even for him. An awfully abandoned boat that could be hiding scary things inside. Rutherford still decided to approach and inspect the vessel to see if there was someone aboard who needed help. This story happened in 2013, but the sailors waited for 10 years before they published the footage. The ghost ship, which turned out to be named Wolfhound, looked like an upscale one, and it probably cost hundreds of thousands of dollars. It seemed like whoever abandoned it was leaving in a rush. There were clothes and other personal belongings all over the main cabin. Some parts of the ceiling had fallen and some drawers had popped open. Rutherford was afraid to open doors in cabins, so he carefully searched the boat step by step, and luckily found no people who would need help. The sailors decided to tow the ghost ship back to Bermuda. It wasn't easy because Wolfhound was bigger and heavier than their boat. After days at sea, the crew was running low on fuel and asked a passing freighter to stop and give them some gas. They kept pulling Wolfhound with just sail power until the tow line got wrapped around the rudder, and they realized they could get stranded in the Bermuda Triangle. So they had to abandon the ship. After another 23 days in the Atlantic, they finally reached Bermuda. As it turned out later, the mysterious ghost ship belonged to an Irish yacht club member. It got caught in a storm with waves that were 20 feet high and super strong winds, and couldn't continue its voyage. A Greek cargo ship rescued the crew, but they had to leave the ship. Rutherford and his crew found the yacht 9 weeks later. Wolfhound is one of more than 50 ships and 20 planes that disappeared in the Bermuda Triangle since the mid-19th century. The first ship, at least officially documented, was the USS Pickering. It departed from Delaware to the West Indies in 1800. There were 70 people aboard. No one ever heard anything from them ever since. And perhaps we'll never know what exactly happened to them and where the ship is now. The largest ship that has ever disappeared in this mysterious area is the USS Cyclops. In March 1918, carrying a crew of 306 people, the USS Cyclops left Barbados and headed home to Baltimore. It had tons of dense manganese ore on board, which was used in steelmaking. Something happened during its 9-day voyage when it was passing through the Bermuda Triangle. The last message from Cyclops said, "Weather fair, all well," and then it disappeared forever, without even an SOS signal. Another ship that the Bermuda Triangle supposedly took forever was the Cotopaxi in 1925. It was loaded with coal and had a crew of 32 people on board. Its trip was supposed to go from Charleston, South Carolina to Havana, Cuba, but something went wrong and the ship disappeared. Recently, scientists discovered that the Cotopaxi was lying at the bottom of the ocean about 35 miles from St. Augustine, Florida. Divers who like to go down to the wreck nicknamed this spot the Bear Wreck, but didn't realize they were exploring the remains of the Cotopaxi. One of them, Michael Barnett, was trying to identify the wreck for over 15 years. He carefully measured different parts of the shipwreck that survived underwater with his team. When they compared these measurements with old blueprints of the Cotopaxi, they saw that everything matched up perfectly. The size and position of the boilers were exactly as described in the blueprints. This helped them confirm that they had found the Cotopaxi, and it looks like there was nothing mysterious about its disappearance. It was a combo of bad maintenance, poor care, and rough weather. Many of the hatches used to access the cargo hold where the coal was stored were either broken or missing. This meant that if the ship ran into a storm, water would easily get into the cargo hold, and the ship would get unstable and sink. As the Cotopaxi sailed off the coast of Florida, it met a tropical storm. Just before it disappeared, it sent out a distress call. It was near St. Augustine, so all the puzzle pieces fell into one place. People have come up with all kinds of ideas to explain what might be happening in the Bermuda Triangle. The wildest one is that spaceships from other planets are taking these ships and planes away. Or maybe it has something to do with the lost city of Atlantis, a legendary underwater city. But there are also more rational explanations, such as the fact that this area often has wild and unpredictable weather, with sudden storms and water spouts. For hundreds and hundreds of years, sailors have told stories about giant rogue waves that seem to come out of nowhere in the open ocean. It sounded like a tale in the past, but in the last 20 years, satellites have spotted these freak waves, some of them reaching over 100 feet tall. Storms from the Gulf of Mexico can hit the Bermuda Triangle area and create such rough and unpredictable waves. Scientists built a model of the USS Cyclops and put it in a wave simulator. They say that even a rogue wave 50 feet tall would be enough to flip over that ship. It had a flat bottom and was less stable and more likely to tip. There are also lots of hills and deep valleys on the ocean floor, which can be dangerous if a ship isn't navigating carefully. Sometimes things can go wrong with engines, communication systems, or other equipment. If a plane or ship has a mechanical problem far from land, it can be really hard to get help quickly, especially if rescue teams are far away. The Bermuda Triangle also has magnetic anomalies, so in some parts of it, the compass might point in the wrong direction. And then there are human mistakes, like misjudging distances, making wrong turns, or not listening carefully to directions. This is what happened to Flight 19, a group of planes that went missing. The leader of the flight, Lieutenant Charles Taylor, decided to fly into bad weather without all the equipment they needed. He was also tired, so it was really hard for him to make good decisions. Disappearances in the Bermuda Triangle don't really happen more often than in other parts of the Atlantic Ocean, where a lot of ships and planes travel. They just attract more attention and talks. You still won't find the Bermuda Triangle on any map, and it doesn't have official borders. So we might never be able to solve its mystery because we can't be sure it even exists. But maybe we need to be worried about another Bermuda Triangle, the one up in space. This space triangle doesn't make things completely disappear, but it messes with the equipment on the spacecraft, causing glitches and makes things stop working for a while. The Bermuda Triangle of Space, which is more officially known as the South Atlantic Anomaly, is a unique area above the Earth that stretches over parts of South America and Africa, from Chile all the way to Zimbabwe. It sits right where a part of Earth's magnetic shield is weaker than usual. When a satellite passes through this area, thousands of high-energy particles, especially protons, hit every square inch of it every second. To keep satellites safe from this radiation, space agencies often put them in sleep mode when they pass through the SAA. The Hubble Space Telescope passes through the SAA about 10 times a day and spends about 15% of its time in sleep mode because of this anomaly. Even astronauts on the International Space Station, ISS, which also travels near this zone, have to be careful about radiation. Parts of the ISS, like the kitchen and sleeping areas, have extra shielding to protect them.
You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light-years wide. For comparison, just 1 light-year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around minus 63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, Some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-Spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system. In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. The recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We've observed such changes for the first time, but they're likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. Now, the inner core of our planet, located about 3,100 miles below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. Now, this outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we really didn't understand its impact on the inner core. But now, the new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core, and that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we really don't notice these changes, but they could influence Earth's overall rotation and length of days. The study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It also allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped, and this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists can also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of our core. But what would happen if Earth's core suddenly stopped spinning altogether? Well, it's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movements, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers or on the floor. The planet would experience something similar, but with tectonic plates. do. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the Sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime or ever. So for now, we're safe. But to truly understand Earth, you need to go 4,000 miles beneath our feet. Earth has four main layers, from the very center to the surface: the inner core, outer core, mantle, and crust. Now, except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 7.5 miles, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 758 miles in radius, which is about 3/4 the size of the Moon. It sits about 4,000 to 3,200 miles below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 9,800 degrees Fahrenheit. It's like the surface of the Sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests that there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 3,200 to 1,800 miles beneath the surface. The heat here comes mostly from the radioactive decay of elements, like uranium and thorium, causing the liquid to churn in massive, turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer, stretching almost 1,800 miles deep. It starts just around 19 miles beneath the surface. Made of iron, magnesium, and silicon, it's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 62 to 124 miles underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 124 miles. But rarer, super-deep diamonds may form as deep as 435 miles. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it's the outermost layer of Earth. It's about 25 miles deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe. The Arctic is disappearing. In just a few years, the North Pole could see its first ice-free summer in the last 125,000 years. But a bold new experiment might turn back the clock. Scientists are refreezing the Arctic. If they succeed, they could save the North Pole. But if they fail, they could trigger unforeseen disasters. So, which way would things go? Well, here's some backstory. Deep in the Arctic, temperatures drop so low that metal cracks and winds scream across the ice. In winter, it's minus 30 degrees Fahrenheit on average. But despite the seemingly extreme cold, it's actually melting, warming 2 to 3 times faster than the rest of the planet. Now, ice is like Earth's natural mirror. It reflects sunlight back into space, keeping the planet cool. When it melts, it exposes the dark ocean underneath. The ocean absorbs sunlight instead of reflecting it, and it spreads all across the planet. This warms the planet even faster, melting even more ice. It's a vicious cycle, and if it continues, we'll reach a point where the ice won't come back. That thick, ancient ice that has covered the North Pole for thousands of years is already 95% gone. It's been disappearing since the 1980s. The ice that remains there now is thin and fragile, and when it disappears, it will trigger a dangerous chain reaction. Meanwhile, a group of researchers from a UK startup called Relocating is out there trying to slow down or even reverse the melting of the Arctic. The project takes place in a tiny frozen village in Canada called Cambridge Bay. Relocating wants to break the vicious cycle, and here's their plan. First, they drill through the existing ice and place an underwater pump beneath it. Then they pump seawater onto the ice surface, where it quickly freezes into an extra thick layer. Finally, they remove snow from the ice, which usually acts like a blanket, preventing further freezing. After that, ice keeps growing, stronger, thicker, and harder to melt. It's a simple idea inspired by nature itself. Ice naturally forms this way in some Arctic regions, but now scientists want to do it on a massive scale. So far, it appears to be working. Between January and May 2024, they covered around 44,000 square feet of ice, and it became 20 inches thicker on average. And in November 2024, they started a new round of tests. In the first 10 days of the trial, the ice was already 4 inches thicker. Now they'll return in May 2025 to check out how things are going. They think it's going to get between around 16 to 31 inches of it during the Arctic winter. It's a small start, admittedly, but if they can prove it works, their plan is to expand across an area more than twice the size of California, about 386,000 square miles of ice. And they're not stopping there. The big idea is to send in 500,000 underwater drones, powered by clean energy, to automate the entire process. These drones would drill holes, pump water, and refreeze the ice without human intervention. But not everyone is convinced. Some scientists think this whole idea is a disaster waiting to happen. First, they point out that saltier ice, the one from seawater pumped onto it, melts faster in the summer. So if this new ice melts too quickly, we could end up making the situation worse. Some of them also think this is a dangerous distraction from the core problem, like treating the symptoms instead of the root causes. Besides, making a small patch of ice thicker is one thing, but doing this across the entire Arctic? That's another challenge entirely. Another thing they're worried about is the ecosystem. The Arctic is one of the most fragile ecosystems on Earth. Changing ice thickness could affect marine life, disrupt algae growth, and impact the food chain in ways we don't fully understand. There's also the question of money. Relocating estimates that refreezing the entire Arctic will cost about $5 to $6 billion per year. Who's paying for this? Right now, they're self-funded with some investors backing them. But eventually, they hope that countries, global funds, and even corporations will finance the project. Relocating argues that doing nothing could be far worse. If we don't act, we could lose the Arctic within our lifetime. That could at least help to buy more time to fix the planet. Desperate times call for desperate measures. Now, the idea of saving the Arctic ice isn't new. Over the years, scientists have suggested some pretty wild plans to stop the melting. In 2017, there was the initial wind-powered pump plan. Physicist Stephen Desch proposed installing about 10 million wind-powered pumps in the Arctic. These pumps would pull seawater up onto the ice, kind of like real ice. It would freeze in the cold winter months, creating a thicker ice layer. The biggest problem is that someone would have to run this entire show. And what happens if something goes wrong? In 2018, there was the Glass Beads Plan, which was supposed to start in 2020s. A team called the Arctic Ice Project suggested covering the Arctic with tiny reflective glass beads. Yep, glass balls. The idea was basically to replace the ice's mirror effect. The beads would bounce sunlight away, keeping the ice colder for longer. The plan is being tested by a group of scientists working with the Arctic Ice Project. They say the glass balls are made of a material that's safe for animals. They even claim birds use similar materials to help them digest food. The glass used in these microspheres is the same material used in lab equipment and light bulbs. Sounds safe, right? Well, not so fast. There's also the environmental risk. These glass balls are tiny, and they could easily get into the ocean, impacting everything from fish to plankton. We still need more research to understand how this material breaks down in the ocean and whether it could affect marine life. But where things get really crazy is when we start talking about scaling this up. To cover just a tiny fraction of the Arctic, they would need millions of tons of these tiny microspheres, and that's just for starters. And they'd have to be working 24/7 through freezing temperatures and snowstorms. The scientists believe this could help keep the ice thick enough to survive summer and even slow the melting. But can it really work? Then, there's also the Bright Ice Initiative, founded by the same folks behind the Arctic Ice Project. Instead of focusing on the Arctic Ocean, they want to use the same glass microspheres to restore glaciers. They've even tried this out on a glacier in Iceland, but experts are still skeptical. They say it could just speed up melting instead of reversing it. Now, another idea was cloud seeding with water particles. This would involve spraying ocean water into the sky itself. This would form clouds, and they'd reflect more sunlight. So, as you can see, some of these plans were too expensive, too complicated, or just straight up wild. The Real Ices plan borrows ideas from earlier projects, but is much cheaper and more practical. Most importantly, it's working. But all this Arctic disaster is already affecting people. In the village of Newtok, Alaska, the land is disappearing. Each year, about 70 feet of the riverbank erodes, taking homes and history with it. That's all because of the erosion and the thawing permafrost. Now, these people had to move to a safer place called Murtavik, just 9 miles away. But it's a long and challenging journey. The relocation is taking years of planning, with Newtok residents already starting the shift in 2019. The new village offers better health and safety, but it's still a work in progress. Things like the school and grocery store remain in the old village, which makes things harder. Water and sewage systems are being set up, and for now, most residents are using a honey bucket system. But at least they have a chance to rebuild. It's still unclear whether these geoengineering ideas are a lifeline or a disaster. For now, we can just keep an eye on them.
You have about $130 million. What would you do with it? Fly into space or buy an island? There are many ways you can spend this much money, but one anonymous investor used it to build an extravagant underwater city. The project is not finished yet, and a lot of people are currently working really hard to make this crazy idea come to life. If all goes well, in the near future, living under the sea may become a reality. In the past century, there was a limestone quarry near the Welsh border in England. In the 1990s, it became flooded and turned into a lake 260 feet deep. Now, there's a large construction project going on around it. Trucks transport materials and people in overalls construct huge modules that look like giant futuristic submarines. These modules are called Sentinels, and they will become the buildings of a small underwater city. Builders and engineers create durable stainless steel materials that allow these houses to withstand a depth of up to 650 feet. This is the upper limit of the twilight zone, where very little sunlight penetrates. Large squid and other creatures live in this zone. Imagine waking up in an underwater hotel room and seeing a giant squid staring at you from the dark. Or even worse,
You see a huge eye watching you as you wake up. This could happen if sentinels were successfully installed in the depths of the ocean. Meanwhile, let's return to our project on a small lake. The project is called Deep. Its goal is to make life underwater as comfortable as possible. Inside living modules, builders install bedrooms, kitchens, bathrooms, and observation windows. People will access them using small submarines. However, it's not as simple as calling a taxi. To live underwater, you need to train under the guidance of experienced instructors to test yourself in underwater life simulators. The cost of living there will likely be expensive, but it's worth it. At least you will be well fed. A chef will develop a special menu, and all food will be stored in vacuum-sealed bags to preserve its flavor and nutrients. It all sounds great, but there's a question. Who is financing this project? No one knows the answer. Deep is funded by a secret investor who has already spent more than $100 million. Interestingly, this is not the first attempt to create an underwater dwelling. For example, Jacques-Yves Cousteau, a famous diver explorer, first created the Conshelf 1 underwater house in 1962. This was a steel cylinder located at a depth of 30 feet, where 2 divers lived for a week. In 1970, several women also spent 14 days underwater in the Caribbean Sea at a depth of 50 feet. The aim of that project was to study human psychology in a cramped environment, similar to that of a spaceship. Unsurprisingly, that project was partly funded by NASA. Okay, we have windows overlooking marine life, delicious food, underwater parties, and solitude away from civilization. All these things sound cool, but if we put aside the fun part for a moment, is there any real benefit to it? Oh yeah, ocean exploration. Many marine biologists believe that the best way to explore the ocean is from within. Diving doesn't help much since divers are limited by time and body needs. They can stay underwater for only about an hour and a half at a time. Underwater cities could allow us to live underwater for months. But the most important thing is long-term observation of marine life in its natural habitat. In the mid-1990s, a group of researchers wanted to study the development and nutrition of corals. They brought them to the lab for testing and found out that corals reacted differently to tests in artificial environments than in the ocean. Their behavior in a laboratory setting was different from their behavior in the wild. Underwater cities could also provide work for archaeologists who study the remains of ships that have sunk throughout history. Plus, such cities could help protect us from future disasters. In the event of a catastrophe like an earthquake, tsunami, or volcanic eruption, scientists and engineers could build water-based shelters like the Sub-Biosphere 2 project to provide refuge for people. These circular structures could sink into the ocean and give shelter for up to 50 or 100 people, allowing them to wait out the disaster from a safe distance. Underwater cities could be an excellent solution to overpopulation, but there are some downsides. We already pollute the world's oceans, and what if we literally lived inside them? It's one thing to use labs to study marine life, but it's another to build hotels for vacationers. One such hotel, called the Water Discus, is a building at a depth of no more than 32 feet. It will have 21 rooms and a restaurant with coral reef views. While the conditions seem comfortable, some experts worry that staying there for long periods could be harmful because of the lack of sunlight. Nevertheless, it would be interesting to stay there for a week and see how it feels. The most challenging aspect of creating such laboratories, hotels, and bunkers is ensuring a reliable life support and safety system. It's crucial that the air, humidity, and temperature be as comfortable as possible for people to live in these structures. However, this requires a significant amount of energy. Currently, all modern underwater buildings rely on external sources of energy located on the surface. But scientists plan to make future underwater projects fully autonomous, using kinetic energy from waves and powerful solar panels to generate power. It's also important to create the right structure for these buildings. Rather than covering an underwater city with a giant bubble, it's more efficient to create several large housing modules. Each module should consist of steel, glass, and special cement. Also, the depth shouldn't exceed 1,000 feet, since a deeper location would require thicker walls because of high water pressure. To load and move these residential modules safely, engineers can use ballast tanks. These are large containers filled with water, which are used to pull the modules down deep into the ocean. Once in place, engineers can release the water from the tanks and fill them with air, causing the house to float back to the surface. And what about fresh air? Fish extract oxygen from the water using their gills, but this method is obviously not suitable for humans. Therefore, we need to deliver air from the surface. It can be piped into the city and mixed with a special substance called sodasorb, which reacts with carbon dioxide and removes it. It would be great if we could generate oxygen inside our underwater cities rather than relying on other sources. This would require farms and plants that can produce oxygen through photosynthesis. But instead of sunlight, these plants would use artificial light. If we talk about complete autonomy, people could get food from the water at any moment, put on scuba gear, a mask, and an oxygen tank, and leave the hotel through an airlock. Use harpoons and fishing nets to catch dinner. Remember to check your oxygen reserves and don't swim for too long. Frying fish in a pan won't work because of strong odors. In an underwater dwelling, air is static like in an airplane cabin, so odors become stronger. Maybe in the future, engineers will create a dedicated cooking area, but for now, you'll have to rely on canned and dehydrated food. If you get bored, go for an underwater walk. Instead of carrying oxygen tanks, use hollow tubes connecting your mask to an air source inside your home. But don't forget that you can't go too far because the length of the tube is limited. Air, food, safe construction. What else? Drinking water. In the future, scientists may create filters in these hotels that desalinate salt water. This water can be extracted from the condensation inside the hotel, as well as from human secretions. Don't be surprised. Astronauts, for example, have been using special technology to filter their liquids and turn them into drinking water for a long time. A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. And pay attention to any unusual animal behavior. Animals have been known to sense danger before humans did, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. Take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the 3rd floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster.
Bet you never heard this story about the Titanic. So, this massive luxury ocean liner was heading out of Southampton on its first voyage to New York with over 2,000 passengers and crew on board. I'll spare you the details for now. You know how it all went down. Since there were a lot of things that went wrong during its short lifespan, some couldn't help but wonder, was it really bad luck? Or was there some mysterious force behind the ruckus? Well, for starters, right as it was leaving the harbor, the Titanic nearly crashed into another ship, called the SS New York. How did that happen? Well, 6 tugboats had to pull the massive Titanic into the river to begin its journey. Captain Smith was in charge, but let's be honest, he probably needed a few more cups of coffee before making any big decisions. So, as the Titanic was speeding along, minding her own business, she passed the New York and the oceanic ships. The Titanic decided to make a left turn, but the suction was just too much for the poor New York. She started to drift off towards the Titanic. The oceanic was leaning so much, her gangplank smacked into the water like a belly flop in the pool. Thankfully, the captain of one of the tugboats was there to save the day. He used his trusty megaphone to call the Vulcan to the port side of the Titanic to pick up some crew members. He then noticed the New York in trouble and acted quickly, throwing a line to slow her down. The Titanic's captain was probably scratching his head, wondering how to handle these big ships like the Titanic. That's because he'd only recently experienced sailing on larger ships. Close one, right? Well, it was just part of the story. As it turns out, the huge list of misfortunes might have started even earlier. Another theory suggests that during the ship's construction days in Northern Ireland, a fire broke out in the coal bunkers. Talk about a rocky start. If this information is correct, then the ship's hull may have been affected by the incident before it even set sail. Fans of this theory argue that a fire popped up inside one of the Titanic's large coal bunkers and really damaged an important segment of the ship's hull. Some claim there's even photographic evidence to back this up. A bunch of photos documenting how the ship was made and pampered for its maiden voyage were found, and they showed a significant black streak on the outside of the Titanic's hull. Weirdly enough, the streak was really close to where the iceberg hit during that cold April. Now I know what you're thinking. This theory might sound far-fetched, but most of these people have been gathering information about the Titanic for decades, and they're convinced that this is the real deal. They even believe that the fire started way earlier than the day the Titanic set out on its maiden voyage, particularly about 3 weeks prior. Why was this overlooked? Well, because of fear of bad press, mostly. Also, because of all the fuss created around the unsinkable ship, it was important that they stuck to the initial calendar. Of course, not everyone is convinced by this new theory. Some people think it's just another wacky idea to add to the long list of Titanic sensational theories. What if I told you there were even rumors about part of an ancient Egyptian coffin being on board? Could that have had something to do with the disastrous ending of the Titanic? Some truly believe it did. let me tell you the story about the unlucky mummy. It's a tale that'll give you goosebumps. Back in the 19th century, this ancient Egyptian artifact, a mummy case lid to be exact, was brought over to Europe. And as soon as it arrived, strange things started happening. Now, some of the stories may be a bit exaggerated, but according to journalists, some of them were actually true. The rumors sparked the interest of a British writer who later spent months investigating the mummy case and its alleged related stories. He was planning to write an article debunking the myths, but he found out they were all too real. Unfortunately, he never got to finish his work because he passed away suddenly. Others believed that the mummy case was guarded by Egyptian elementals. They warned others not to mess with the artifact. The mummy case's history is just as spooky. It was found in Egypt and sold to a certain someone conveniently named Mr. W at a party organized by a well-known English lady. When the mummy case arrived in England, it was given to Mr. W's sister, who immediately suffered from financial losses and other troubles. A photographer who took a picture of the case claimed that he captured a living woman's face on the film. The mummy case eventually ended up in the British Museum, and it's still there today. However, rumors say that it was aboard the Titanic and was responsible for its sinking. But don't believe everything you hear. Some sources claim the mummy case never left the British Museum, and the rumor was started by a journalist named William Stead. He was actually a passenger on the Titanic, and he supposedly told his fellow passengers about the ill-fated mummy before the ship went down. Is that what happens when you tempt fate? Seriously doubt it, but it does make you wonder, doesn't it? It gets even weirder, trust me. About 50 passengers got cold feet before the ship took off, and they refused to board the Titanic at the last minute, even if it meant that they'd lose the cost of the ticket. They just had an extremely bad feeling about the whole deal, and even an Irish astrologer warned against making the voyage on the Titanic. I doubt he saw a big ol' iceberg hidden somewhere in the stars, but it does add up to the mystique surrounding the Titanic. And do you know what's even worse? The fact that the ship's binoculars, which could have helped prevent the iceberg collision, were locked up. Apparently, those binoculars could have been used by lookouts on that fateful night. But guess what? The key was held by David Blair, an officer who was sadly bumped from the crew before the ship's departure. Poor guy. He probably didn't even know what he was holding on to. Now, some historians think that if those binoculars were in use, the iceberg might have been spotted earlier. But hey, let's not point fingers here. Others argue that it wouldn't have made a difference. Who knows? Maybe the lookout was too busy looking at the stars to notice a giant iceberg in front of them. But seriously, what were they thinking? Locking up the binoculars on a ship that big is like forgetting to pack sunscreen for a trip to the beach. Also, the ship might have been going a bit too fast. Now, I know what you're thinking. Why was the captain in such a hurry? Well, apparently, good old Captain Smith was trying to beat his ship's older sibling, the Olympic, in a race to see which ship could cross the Atlantic faster. I guess he had a bit of a sibling rivalry going on or something. But here's the thing. Even though there were warnings about icebergs in the area, the Titanic just kept on chugging along at full speed ahead. I mean, come on, guys, it's not rocket science. If you know there are icebergs around, maybe slow down a little bit, right? And then, close to midnight on April 14th, 1912, the Titanic hit that iceberg and sank in the North Atlantic. It also famously had a mere 16 lifeboats and 4 collapsible dinghies on board. No wonder it ended up being one of the worst maritime disasters in modern history. After the whole event, people started believing in life beyond the veil and contacted mediums, hoping for signs from the ones they had lost at sea. Can't say I blame them, though there's no verified story of someone managing to contact a Titanic passenger from the beyond, though.
Did you know there's a guy who rode on a wave for 7.5 miles? It was accomplished by Brazilian surfer Picaruta Salazar in 2004. Just for comparison, Central Park in New York extends for a mere 2.5 miles. That was the Pororoca wave, and it can only be surfed for 3 days a year. It's pretty powerful, so it sort of pushes you. But there are definitely some tough spots where it's not that easy to catch waves. If you're looking for the gnarliest surf spot, Pipeline in Hawaii is where it's at. But beware, it's not for the faint of heart. This place is known for its massive waves that can reach up to 20 feet tall. And did we mention the shallow reef? Yeah, wipeouts here can result in some serious injuries, or worse, you might end up sleeping with a fish. The waves at Pipeline are also super unpredictable, so you never know what you're going to get. It's like a box of chocolates, except instead of chocolate, it's huge waves that could crush you like a bug. But hey, if you're feeling brave, the annual Billabong Pipe Masters competition is held there every winter. Just make sure to bring your A game and a change of underwear. Even the most experienced surfers approach Pipeline with caution and respect. It's like trying to tame a wild animal. One wrong move and you're toast, or dinner. So, if you're ready to ride the gnarliest waves in the world, come on down to Pipeline. Just don't say we didn't warn you. For those who are dreaming California, there's a tough spot in the Golden State for you. Mavericks is notorious for its massive swells and strong currents, making it a challenge even for experienced surfers. Hold on tight, because this wave is gonna take you for a ride. First off, let's get one thing straight. Mavericks ain't for the weak. This bad boy can reach heights of up to 60 feet. But hey, if you're a seasoned surfer and you're feeling brave, then Mavericks is the place to be. Located just off the coast of Half Moon Bay, this spot is known for its massive swells and killer waves. It's like the Hulk of surf spots, big, bold, and ready to smash. Now, don't go thinking that Mavericks is all about the waves. Oh no, my friend. This spot is also home to some of the coolest surfers around. These dudes and dudettes live for the rush of catching a maverick wave, and they'll do whatever it takes to get out there. But here's the thing, Mavericks isn't just about surfing, it's also about community. These surfers have each other's backs, and they know that when they're out there on those massive waves, they're all in it together. It's like a big, salty family. So there you have it, folks, Mavericks, the wildest, most insane surf spot in California. If you're up for the challenge, grab your board and head on out. Just remember, when you're staring down a 60-foot wall of water, it's okay to scream like a little girl. We won't judge. Teahupo'o in Tahiti also has some of the heaviest waves in the world, breaking over a shallow reef and creating intense barrel rides. First of all, the name itself is a mouthful. It's pronounced Teahupo'o, and it means broken skulls in Tahitian. Yeah, you heard that right, broken skulls. The waves at Teahupo'o are massive and can reach up to 23 feet high and break over a shallow reef, which creates a super powerful wave that can barrel for hundreds of yards. And if you wipe out, well, let's just say you'll be getting up close and personal with that reef. It's like a cheese grater for your skin. So make sure you bring some Band-Aids and a good insurance policy. But hey, if you're up for the challenge, Teahupo'o is one of the most epic surf spots in the world. However, I hope you're going to choose a much safer spot. If you're looking for some cool waves but don't want to risk your life, then you gotta check out these safe surfing spots around the world. First up, we got Waikiki Beach in Hawaii. This spot is perfect for beginners and pros alike, with consistent waves and a sandy bottom. Plus, there are lifeguards on duty to keep an eye out for any trouble. Next, there's Bondi Beach in Australia. This iconic beach is known for its beautiful scenery and chill vibes, but it also has some great waves for surfing. The water is shallow, and there are plenty of surf schools around to teach you the ropes, or in this case, the boards. But if you're looking for something a little more exotic, head over to Nocera in Costa Rica. This spot has warm water, consistent waves, and a laid-back atmosphere. Plus, the locals are super friendly and will welcome you with open arms. Last but not least, there's Muizenberg Beach in South Africa. This spot has some of the most consistent waves in the world, but they're not too big or dangerous. Plus, there are shark spotters on duty to keep you safe from any unwanted attention from local carnivores. But no matter how safe the spot is, you're still going to need some cool life hacks to bring your surfing to a brand new level. Have you ever wondered why surfers use wax on their boards? Well, let me tell you, it's not just for show. See, when you're out there shredding the gnar, you don't want to slip and slide all over the place like a penguin on ice. That's where the wax comes in. Basically, the wax creates a grip on the board so you can stick to it like peanut butter on bread. Without it, but here's the thing, not all wax is created equal. You gotta find the right kind for your board and the water conditions. It's like choosing the right flavor of ice cream for your cone. You don't want to end up with mint chocolate chip when you really wanted Rocky Road. So, next time you see a surfer waxing up their board, just remember they're not doing it for the smell, although some waxes do smell pretty sweet. They're doing it so they don't wipe out and embarrass themselves in front of all the folks on the beach. And that's worth its weight in gold. And by the way, did you know that rubbing a little bit of wax on the bottom of your feet can give you a better grip on your board? Yeah, it's like magic. No more slipping and sliding around like a seal on a wet rock. Another common hack is to wear earplugs. You see, there's even a condition called surfer's ear. Surfers are constantly exposed to cold wind and water, and some of them even surf in cold temperatures. If your ears are constantly exposed to cold, your ear canal may shrivel up. As a consequence, water, wax, you, and even air all get trapped in your ear, which may lead to certain infections. So, to prevent water and cold air from getting trapped in their ears, pro surfers like to use earplugs. But even if you're just a newbie, you gotta use their tip. Oh, and here's another classic. If you're surfing in cold water and don't have a wetsuit hood, just rub some petroleum jelly on your ears to keep them warm. Hey, why do you think some surfers have clear nail polish on their emergency kits? It's not for their nails, but for their boards. So, if you're dealing with a stubborn ding in your board, grab some clear nail polish and fill in the crack. It'll keep water from seeping in and causing more damage. However, pros will say that nail polish is a terrible idea, and there are a lot of repair kits out there. Yeah, this one's up to you. So, there you have it, my fellow wave riders. Now go out there and shred those gnarly waves like the pro you are.